all of the vertices that you can see, which are orange here, those indicate that they're actually shared with another bone, and that's because we've got an overlap in these envelopes here. So these colors indicate the degree of rigidity that the vertices are actually stuck to that particular bone. Now these overlapped areas give us a nice blending between the two bones, so we don't get a sharp cutoff between the two. Now I've left it this way. You can actually bake the vertices down, and this is preferable in most pipelines. But let's say in this circumstance we just wanted to use envelopes and it was working just fine. And then let's say a producer comes along and says, you know, I want the mesh to be wobbling around while it's bending and flopping around. So you put a noise modifier in there in the stack, and actually I've got turned off end result there, and that's why it didn't actually update there. But if I actually turn that on and we play the animation, you can see it's all looking fine. And you know, producer comes along, he says to us, I'd like to have the mesh deforming as well. So you put a noise modifier in there before the skin modifier, and you can see us deforming the mesh, and that's looking pretty cool. And I've set it to animated, so as time goes on that's going to actually deform the mesh around. I'll just turn off skin for a second just so you can see how that works. So you can see it's causing the mesh to sort of twitch and wobble and distort around. So that's looking pretty cool. That's just the way the producer wanted it. So we'll turn on skin and we'll play the animation, and you can see you've got a horrible mess. And the reason for that is the actual deforming of the mesh, which is being carried out by the noise modifier, that's actually pushing the vertices of the mesh outside the envelopes, which are coming above it in the stack. So whereas originally those vertices fell nice and neatly within those envelopes, now they're being pushed outside those areas. And so as the stack is evaluated, you can see it's just producing this horrible mesh. You can see the vertices are going outside the envelopes and they're going into their non-distorted position. Then they come into the envelopes and then they are being distorted by the skin and so on. And it just looks dreadful. Isn't it really not what you want? So you think, okay, let's get rid of that noise modifier. We'll just turn that off. And if you play the animation, you'll find that it's working again, except that it's not working again. You can see it's still actually broken. Now in this case, to fix this is actually easy enough. You just go into the skin modifier, go down to the a button here in the advanced parameters, which is reset all bones. That'll actually reassign the vertices using the current envelopes that you set up. So if I just hit that button now, and now if you scrub the timeline, you can see that's working again. So in this case, it was easy enough to recover because we were using envelopes, and it was easy enough to actually just press that button and get our assignment working again. But you know, our producer's still breathing over our shoulder, and he still wants this distortion to take place in the mesh. So in this case, the easy thing to do is to actually just move the modifier to a different part of the stack. So I'll just get rid of oops-a-days. I'll just get rid of this modifier here. What we'll do is we'll just grab it, this noise modifier, we'll put it above the skin, we'll turn it on again. Again, you can see we've got our distortion, and if I play the animation, you can see that the skin is still taking its effect, but you can see that the noise modifier is then being applied to our mesh. So you can see that in this case we've definitely got topological dependency going on, and it's pretty important which order you actually create your character in. So this is something to bear in mind when you're working with characters, when you're working with skin, when you're working with a morpher, when you're working with any sort of deformation that might happen. It's very important that you do a little bit of R&D and you find out which order you can actually do your deformations in. And you know, do you have your deformation before the skin? Do you have it after the skin? What are the upshots of doing it in different orders? And it's really important that you find out, you know, exactly what happens when you do things in one order or another order. So that's it for skin. Let's have a quick look at morphing before we actually finish off this chapter. I'll just hide our little character. I'm not exactly going to win any Oscars for that particular rig or modeling setup, but anyway, it demonstrated a point. The next point is the morph modifier, and again this is pretty not morphologically, topologically dependent, and I've got some examples here of how things can go awry. In the middle, well, just off the middle here, we've got our morph object, and let's say this is a character, and we've got these morph targets which I've set up here, and the first problem we can actually get is that the vertex count in one of our morph targets, and when I say morph target, I mean a mesh which has the same vertex count as our original mesh, but which is deformed in some way. And then what the morpher does is it uses the differences between the original mesh vertex positions and the deformed mesh, and it uses that as the basis of a deformation. And then you can dial up and down a spinner, and that will actually affect your mesh and deform it into the shape of the target. And this is called morphing because it's a metamorphosis between two different shapes, and it's a standard kind of thing that you see in CG. In Maya they're called blend shapes. It's still morphing in Maya, but they're called blend shapes, and they in Max we call them morph targets, and it's just down to terminology at the end of the day. Now, if we look at this if we look at this original object and we bring up its properties, you can see it's got 154 vertices. So if we go over to this object over here, it looks pretty much the same, but I've actually gone in and edited the mesh here. And you'll have a look at the vertex count, and you see it's actually got 158 vertices. So to assign a target to the morpher, you just put the morph modifier onto the object. You've got all these different slots here. You can have, I think, 100 different slots. So there's plenty of scope there to create your nice morph setup. You right click on a slot, pick from the scene, go over to the target. You can see I've got these here, and when you're over a valid target, you can see it turns into a little crosshair like this, so it just indicates that you can click on that and turn that into a target. If we go over to this object, you can see it's not actually changing into a crosshair, and even though it's transparent in the viewport, what Max is obviously doing is it's interrogating the object underneath the pointer, having a look at the vertex counts, seeing if they're equal, and in this case they're not. So it's a very, very minor little edit that I've done here to the actual topology, but it's increased the vertices, and because of that we're not going to get a morph target, a valid morph target out of this object. Now this object here is a valid morph target, so I'll just click on it, and if we dial the spinner up and down, you can see it's actually deforming our mesh, and you can see at 100% it's actually exactly the same as the target mesh over here. And I think you can actually unlimit that as well. At the moment it's limited. If I unlimit that, I can actually go above 100 now, and it carries on deforming the mesh, and I can actually go below 0, so I can actually deform the mesh in the opposite direction as well. So you can see it's a pretty cool system. I've built characters with it before, and I've done facial rigs, and you can get some really nice facial animation out of this system. Now the last mesh in the row, I've actually fiddled around with that quite a lot, and I'll just dial this morph target back to 0, so we've got an undeformed mesh. Our vertex count in our original mesh is 154, and I've been careful in modeling this object so it's got 154 vertices as well. But you can see I've actually deleted some edges and some vertices there, and I put in an edge here, and we've got some extra vertices there. So you can see I've done the same here, and I've made other modifications here. So it's actually a valid morph target because it's got 154 vertices. So we'll go over here to our original object, and I'll just click on here, pick from scene, go over to this object and pick it, and you can see there were no complaints. It picked the object and it's added it to our morph modifier. But the vertex count has changed in that object, and the topology arrangement has also changed quite radically. So if I scrub the spinner up and down, you can see we're not really getting the same kind of deformation as what we would expect. We're getting a sort of twisting going on. We've got some weird stuff going on here. You can see the side of the mesh is completely broken up, and it's really badly distorted. Now in this case it's actually quite a simple object. If it was a really complex object like a face, and you had even minor changes in the topology but the vertex count were the same, when you actually did a deformation like that, it would look pretty horrific. You'd have your nose moving up onto your forehead and the eyeballs popping out, and the cheeks sucking inwards. It just wouldn't look very pretty. And you've got to be very careful when you're building morph targets, especially that you don't change the topology in any way. and you've got to be careful all